Okay, hello, I'm Carlos Seo from Linaro, and today I'll be talking about how to build the GNU C Library with the LLVM toolchain. So, wait a minute. Okay, so this is an internal proof of concept at Linaro, and you may be wondering why we decided to do it. So the first thing was we wanted to allow glibc to be built of different compiler. The second thing that we wanted to improve the glibc code coverage by using the clang set of compiler warnings. We also wanted to improve clang by adding features that were initially developed for GCC. And we also wanted to verify any performance difference in glibc between the two compilers. And since glibc is a dependency for many Linux packages, we wanted to open the possibility in the future to build a full Linux distro with LLVM. So the challenge of doing this are huge, because first, the glibc uses a GNU C standard, so it relies on GCC extensions for a lot of things. It also assumes that the default assembler and linker come from binutils, so that generates another layer of dependencies. Some of these GNU extensions were already discussed in the community and will never be implemented by LLVM. And there are some other extensions like 128-bit floating points that are not fully compatible between the compilers. So what we're doing now, what we have been doing now, we removed all the GNU extensions that we know that LLVM will never implement. We have adapted the build so that glibc can use LLG, and we refactored the code in some points to remove these hard dependencies between GCC and binutils. And this POC is available at the official glibc repository at Sourceware under Ademir Balzanella's branch, who is our colleague who did most of the work on the glibc side. And all of the work that we mapped that should be done, we did about a third of the work in glibc to allow the build for x86 64 and AR64. We did about 2/3 of the work needed to build all the test cases in the glibc test suite. And this work was done using LLVM 18 and the GCC 11 runtime. So by the time LLVM 18 released, all the patches that we needed to allow this build to work were upstream already in LLVM. And since it's a POC, there are some limitations. So the GNU func support is not complete. Gmon support on AR64 is not really working because of ABI difference between compilers. There are several code gen issues in the test suites, in the math test suites, mostly for long double and float 128. And we currently don't have any support for the LLVM runtime. So you can use the LLVM libgcc wrapper to get around this, but there are a lot of bugs, so it's not really working at all. And with that, there's a lot of things that need to be done. So besides all the work that needs to be done on the glibc side, on the LLVM side, we need to try a lot of extra support in compiler RT and libunwind. So glibc relies on libgcc for a lot of things like thread cancellation and unwinding, software floating points. And these things are very different between the GCC runtime and LLVM runtime. And so we need to add some missing symbols that glibc uses for thread cancellation. We need to add extra routing modes for floating points because currently LLVM only supports one routing mode. And there's another problem in software floating point because all of the symbols in the LLVM runtime are public. And for software float points, that will generate PLT stubs for every single software float call, and that's something that we want to avoid. And so this is pretty much all I had for today, or for status on this project. So this in our POC can be used experimentally. Like I said, it's available on the SourceWare repository, so you can download it and build it. Last I checked, it's also working with the current LLVM, so you can use the top of the tree to build that. And if you're interested in this project, please do not hesitate in contacting us. We are looking for people to work with us on this port. So and that's all that I had today. Thank you.